So, good afternoon, everyone. Welcome to the end of the first day of Software Architect. Unless you've been to the workshops yesterday, in that case, welcome to the end of the second day of Software Architect. In this session, I'm going to show a lot of demos, but most of them are going to be, well, web browsers, management portals, and some minimal coding. That is because we are all software architects and not necessarily developers. And if we would have come here to see code, I would have made you stay for the entire day because that would have been a lot of code. Okay? Because what we are going to see here in this next 60 to 90 minutes is how I can take a web application that I developed primarily on premises that is working with a local SQL server and the local database for identifying users, and migrate this entire application to Microsoft Azure and replace all the components that are used locally with components from the cloud. Okay, so that is what we're going to see. And just before we begin, just to introduce myself to those who didn't come to my workshop yesterday, because I see some familiar faces. My name is Ido Flatow. I'm a software architect from Israel, dealing a lot with Azure in the past couple of years. Both architecting application for the cloud, migrating customers from on-premises solutions and even other cloud solutions to the Microsoft cloud, to the Azure cloud, writing training kits and courses about Azure, even wrote a couple of books, not about Azure, but about other stuff. But I do a lot of Microsoft consulting, a lot to do with .NET, databases, IIS servers, cloud development, etc. So if there is anything to know about cloud, I bet I'm your guy. So try me out at the end of the session with every question that you have. So what are we going to see in the next couple of minutes? We're going to see an on-premises web application that I developed that is using, of course, a browser, a web server, and a SQL Server database. And for authentication, the application is using the ASP.NET Identity System. So first of all, before I begin, how many people here define themselves as web developers or web architects? Many. OK, that's great. How many people here, by the way, ever used Microsoft Azure? OK. How many people are going to try it out at the end of the session? Everyone, raise your hands. OK. So first of all, I want to show you the application that we're going to migrate, just so you'll know what I'm going to talk about. So in this Visual Studio, and by the way, I already provided the entire solution, including all the projects online. At the end of the session, I'll give you the link so you can go ahead and download the code. You'll probably see my keys and my URLs there, so don't worry, I'm going to delete all the resources later on, so you can't use my Azure Active Directory and my storage account. I'll delete those. So first thing, I'm going to show the basic application that I'm going to migrate. So this is an application that is using my local IIS Express. It's using a local SQL Server database, and it's in use. Let's just close some stuff here. Let's try that again. OK, so this is a local web application. The database that it is using is a set of two databases on premises using SQL Server Express. I have one database for my application database, where I have all my entities, all my resources, and another database to manage my users. I'm using the ASP.NET Identity System, what was once known as the membership provider, if you're familiar with that. So this is the application. This application manages secret agents, such as this guy. Oh, no, sorry. Have to authenticate first, of course, login. That's kind of weird, an application that shows you a list of all the secret agents before you're actually authenticated. So I need to discuss this with the architect, which is me. Okay. And now we can see this guy, or for example, I don't know, this guy. Familiar with him, right? Okay. Everyone knows who this is. So this is my application. The entities that you see here were retrieved from this database, the agency DB. You can go ahead and select the rows from this table. Okay. My management system, my user management system, is using the agency user database. As you can see here, my ASP.NET users. Okay, here are my users that I manage in the application. So the first thing I want to do is to think what I'm going to do with this application, how I will migrate it to Azure. So in this session, what we're going to do is we're going to show a couple of things. First, I'll try to move my database to the cloud because I can't use an application that is in the cloud with a local database, right? Next, I'm going to see how I'm going to handle different resources that I have, files that I'm uploading to the server, local resources such as images, scripts, that sort of things, and how I'm going to manage that in the cloud. Next, we're going to talk about hosting, how to actually upload a web application to the cloud, how I'm supposed to host that, which solution is the best, and how we actually do that, and of course, we'll show a demo. Then we're going to talk about scaling, session management, cacheability, and that sort of things. And of course, we're also going to talk about authentication, not because I'm a security junkie, but because when we move to the cloud, it's better to use the cloud support for security and not continue to use the ASP.NET identity system, of course. So the first thing we're going to talk about is SQL databases. So of course, in the cloud, you don't have to use the built-in components for databases. You can just create a virtual machine and install SQL Server on that machine. But why would you want to create a virtual machine and install a database and have a DBA to manage that, or a team of DBAs, and manage the backups and the scalability and the reliability of those machines, where instead you can just click in a browser and create a new SQL Server as a service, okay? So this is one of the options that we have in Azure, to create a SQL database that you get as a service, as a managed service that you can actually just create in a click, even scale in a click. I can create a small 2 GB database and increase it over time to a 500 GB database that, of course, will cost me about 100 times more, but at least I won't have to manage that migration. I get a database that is backed up. I get a database that has copies, okay, a replicated copy both locally and even geo-replicated to another data center, of course, if I pay enough money for that. Okay? Everything depends on how much you're willing to spend. So we have different offerings of SQL databases, and eventually it will be wiser to use those solutions instead of creating your own SQL Server virtual machines. Okay? So how do we do that? How do we migrate our application from using a SQL Server that is locally to a SQL database in the cloud? So first, of course, we need to create that SQL database in the cloud. Okay, we'll see how to do that. Next, we need to migrate our databases, right? Export them from the local storage, from the local SQL Server, and upload them somehow to the cloud, and then import them and create a database based on those backups. Okay? We probably need to do that twice, once when we develop the application and another time before we go to production, where we'll probably need a couple of hours of downtime in order to back up the production database and upload it to the cloud. Lastly, change, of course, the code. I mean, it's SQL database. It's not a SQL Server virtual machine, right? So we probably need to change the code. We probably need to change how we use queries, how we use ADO.NET. If we're using Entity Framework or an Hibernate, we probably need to do that. To make long story short, you won't have to change your code. SQL databases in Azure actually use the same protocol as SQL Server machines, meaning that I don't have to change the way I access the database. The only thing I need to change in my code is, well, the connection string. Just point to the SQL database in the cloud instead of using my local SQL Server. Other than that, I don't need to change any of the code. That's because when I primarily designed my database, I designed it to be easily migratable. Of course, if your database is, I don't know, 10 or 15 years old, and has issues like tables without proper primary keys, related tables without proper foreign keys, non-clustered indexes or clustered indexes, you might have some issues migrating your database. Luckily, when we perform the export, there is a tool in SQL Server, at least from 2012 and on, there is a tool that is called export application that creates a backpack file, BACPAC file. I have no idea what the acronym of that file name is, but that's basically a backup of your entire schema plus data. And once you issue that export, it will actually tell you what features are missing or not supported when you will migrate it to SQL databases, and it will actually inform you in each table and each column if it's correct or not and what you need to fix. So you won't have to complete the entire process of importing it to Azure just to find out you can't use that. So even while you'll export the data, you'll get the proper messages if you can do that or not. Okay? And of course, fix it and then export it again. So let's try to do that, and then we'll discuss some of those disadvantages that are listed on the bottom. So as I explained before, the first thing I need to do is not change my code. Okay? Instead, I just need to create the database and export my local database to Azure. So let's start with exporting my local database. I'll go to my management studio. I have the two databases here. Let's just close these. And what I can do, I'm using the management studio of SQL Server Express. I don't have a full-scale SQL Server machine, and there's a bit of a difference between the management studio of Express and the normal SQL Server. I'll explain shortly what I mean. When I go to tasks, I have the option of export data tier application. That will create the backpack file. In this version, when I export the data tier, it tells me to select the local disk path or to select Windows Azure and save it in some storage account. Okay? I can do either of these. In the full management studio, you actually have a third option of creating a database in Azure from your local database. So it does both the export and the import. Okay? I will have to do these two steps, but you actually can do that in one step if you have a full SQL Server. So let me store that locally for now. This is the agency DB. And in the meanwhile, I can do the second one. Yeah, that's done. It's a small database. It's about 60K in size. Of course, your databases are probably gigabytes, if not terabytes. If it's terabytes, I hope you have enough bandwidth to upload it to Azure. Okay. If not, by the way, Azure also has the option of sending them hard drives with the backup of the database, and then they will just put it in storage for you, which might be better than to upload an entire 10 terabyte file to Azure and wait for 12 days.
Just a quick question.
Yeah, quick question.
Which ports need to be open for you to be able to communicate from SQL Server through to the Azure database?
So to communicate from your local machine with a SQL database, you mean?
Yes. Obviously, I'm assuming that since we're talking Azure, we're talking about enterprise development, not someone sitting at home playing around.
Either way. I'm sitting around at home and playing with Azure. If you want to use SQL databases in the cloud from your enterprise or from your home, you need to make sure that you open the SQL Server port in your enterprise firewall and in an outgoing port in that case, the destination port that you're connecting. The SQL Server port is 1433, if I'm not mistaken. That's the same port as a local SQL Server machine. But what you will need to do, and I will show it in a couple of minutes, you will need to do the opposite. You actually need to tell SQL database in Azure which IPs can connect to the database, because you won't want the entire world being able to connect to your database. Okay, so that's one thing I need to do in a second. So let me just create the agency users backpack. Okay, and we'll do this. Close. So now we have 2 backup files, and we need to create database from those 2 backup files. So let's move on to the management portal. And how many people are familiar with the 2 versions of the management portal? We have the new one and the old one. How many people know the old one, the existing one? I don't like to call it the old one because for me, this is the main one that I'm using. Okay. How many people have tried the new one? Yeah. How many people are not going to try it because it looks strange? Right. Okay. From what I know, people either like this new portal or hate this new portal. They just didn't tell me how many people actually like it because I don't think it's a lot. This is recorded, right? Oops. Okay. Maybe they will deny me MVP for that next year. So the first thing I want to do is to create a database server. In SQL databases, we have 2 things that we need to create. There is a SQL database server, just like we create a SQL server and installing the entire application on a virtual machine. We need to create this server. This takes about a couple of seconds. And the second thing I need to do is to create a SQL database, the database itself in the server. Just like we are installing SQL Server machine and then deploying a database to the machine. So I'll go to SQL databases, go to servers, and here I have the option of add. The reason why I need to create a database, that database server is going to host all of my databases. When I create a database server, I have a quota of the amount of databases I can create in that server. So as I go along and create multiple applications, I might need to create multiple servers. And of course, each server is positioned in a specific data center. So if I want to build a bunch of databases in the US and in Europe, I need a couple of servers in both places. So I can go ahead and create the database server. By the way, one issue with database servers, it's not an issue, just to know this out. You can't set the name of the server. It's randomly generated. Okay? That is why you don't see a server name, only login name and password. And the region will be North Europe. Okay, here I have a checkbox, allow Windows Azure services, they haven't changed it to Microsoft Azure for some reason, to access the server. That means that any application that is deployed in the data center meaning using either of the hosting options of Azure, virtual machine, websites that we're going to see, cloud services, mobile services, either of the hosting strategies of Azure will be able to access this database, of course, if you know the username and password. Okay? This is because SQL database servers have a firewall. I'll leave that checked because we are going to deploy our application to Azure. If you don't want the database server to be accessible to other Azure applications, you might want to host your application, verify the IP that you get for the application, and then uncheck that option and only enable that specific IP to access the database server. So as you can see, the database was created. The only issue is I don't know which database was created, NXER, this one. And I mentioned the firewall, so here let's go and configure the firewall. So as you can see, currently only Windows Azure services can access the server. And if I want to develop against this server, for example, to open Management Studio, connect to that database that I'm going to deploy and run a few queries, or even run the web application currently locally and access the database in the cloud, I will need to enable it at least for my IP address. Okay, now, since we're in a conference, maybe the IP is going to be switched. I'm going to do something that you should never do in production. I'm going to allow all the addresses. Never do that in production. Okay. Of course, it will take a couple of minutes for it to actually work. In the meanwhile, we can import our databases and configure our code. So to import a database, the easiest way to do that is to just click New, Import. Okay. And now I can choose a backpack file, but as you can see, it has a backpack URL. This is not a local file that is going to be uploaded. Instead, I'll need to upload it first to, say, blob storage, which is where we keep files in Azure, and then point to that location. By the way, if you recall back when I exported the data just a couple of minutes ago, I had that option to export it to blob storage instead of locally. Okay? The only reason I didn't do that is because I want to show you this cool application that allows me to copy files to blob storage. So I have this nice utility that I downloaded. It's called Cloudberry Explorer. I'm not advertising them or anything, just a cool utility. And I'm using that to connect to my blob storage on the left and my local hard drive on the right. And let's go to a blob storage that I have. There's a DB backup here. And let me just remove these two. Just so I won't get confused. And let's copy these two here. Okay, these are small, it didn't take too long. And now I can go back here, click the backup URL. As you can see, there is a list here of storage accounts that I own in this subscription. I copy the files here to DB backup. So I'll select the first one. And this is going to be agency DB. Let's call it the agency DB, just like, no, let's keep it agency DB. I can select any one of the tiers that I want. The web and the business are the old ones, so I won't pick them. We'll select, for example, basic. The difference between basic, standard, premium is the amount of transactions per second that you're able to get. Okay, and of course, the more you want, the more you'll pay. So I don't want to pay much. I'll select the basic for 2 gigabytes. This will cost about $12 a month, which is even less than a license for a SQL Server database, okay, which is usually $20 to $30 per month. I'll select my new database server, the login. Okay, the database is being imported. Shouldn't take long because it's a small database. Of course, if it's a larger database, it will take longer. In the meanwhile, we can try and import the second one. So DB backup, users. Again, let's choose basic, server. Could not import agency DB. Why is that? Encountered an internal error. Who is using the network currently to download movies? Please stop. Let's see if it's able to import this database. Give it a second. If not, we have a backup, don't worry. I already have these databases loaded. Here they call the agency DB and the agency user just in case something went wrong. Okay. I prepared in advance. This is taking a lot of time. Maybe the internet connection is down. I know why. Let me just pause this. Okay, yeah. Don't back up your machine to the cloud while you're doing a demo with the cloud. Let's see if that works. Yeah, okay. Okay, yeah, it's taking a bit of time. So successfully checking import status. I think that it's actually imported already. Let's try to refresh this. Yeah, temporary internet issue, but if it doesn't work, we have a backup. Okay, question is in the meanwhile, while we are waiting for the management portal to load. No, not working. Okay. Probably just a temporary issue, but for now we'll just stick with the databases that I already imported just yesterday evening. Let me see if I can do that again. Just try that. Import backup URL. DB backup. Basic 2. This one, right? And XE. Next. cross your fingers. Successfully submitted. Usually it doesn't take more than half a minute. Something is probably wrong with the database. I don't know. Well, in any case, since we have this database already here, let me just show you how I can actually connect to them to see if they were imported correctly. All I need to do is to check where these databases are stored. Oh, it was imported successfully. Then I can continue with the demo. Agency users and agency DB are here. Great. So let's just check these databases. These databases are hosted in the server that you see here. Okay. Let me just zoom in a bit. Let me just copy that. This is the name of the server that was created before. I can just go to the management portal now and connect to that server using SQL Server authentication. Just remove that. The password. And as you can see, I can even manage this SQL database server for my management studio. I can just open the databases, open the tables, use select statements, whichever I like in order to check this database, even create backups, copy it locally to my SQL Server database. Okay, so now all we need to do is just change the connection string. So I already have a copy of this application just here, just so I won't need to change my base application. So we just go to the web config, and this application is already configured to use the cloud, so I'll just manipulate the connection string to point to my new database. So let's just replace this with the address of the new server. And the database is called agency users and agency DB without the V in the beginning. Let me just check the names. It's not case sensitive, agency users, great. And I just need to change the name of the database in the login, copy and paste. I'm always using the same password, just not in my Gmail accounts or Facebook accounts, so don't try to use that password. But all my Azure accounts are using this password. And right now, if the firewall is already opened, hopefully it took more than 5 minutes, then I can just save these settings, set this project to a startup project, and run this. And if everything works, the application should run just as fine as before because it's using now the database in Azure. If there is any problem, we'll probably see an exception message, and we'll just handle that if it comes. So let's check. Close this one. OK, application is loading. I got the names here, so it's probably working, and it's actually showing me that I've already signed in, which is great, and I can get the information. Okay, so I was able to connect to my SQL Server. If I'll add the user here, you'll see that in that database and not in my local database. I can actually go ahead and delete my local database. I just won't do that because maybe I'll have another demo later on. But the application now is working, and in regards to the disadvantages that I mentioned before, there are a couple of disadvantages of using a SQL database as a service. So the first one, as listed here, the maximum size currently is 500 gigabytes. Now, of course, there aren't many companies that need more than that, but I already had a couple of companies that said 500 gigabytes, that's too small. We need 10 terabytes of data. How many people here need more than 500 gigabytes of database? Oh, you're in a good situation. OK, so you can all use SQL databases. So the performance here is good. It's actually great. It's not excellent. I had a user, a customer, who asked me what's the maximum performance I can get in a SQL database, and I told him it's about 720 requests, transactions per second. That's a lot. He said, OK, I need 5,000. Okay, then create a bunch of SQL Server virtual machines with a lot of hard drives and with a lot of CPU, and you'll get to 5,000, but not in SQL databases. Okay, so the performance is good, but it's not as excellent as you might want it to be in the high-end scenarios. Okay, and there are a couple of differences between SQL Server and SQL databases. I provided a link at the bottom of the slide that shows the entire list, but basically you can create views and tables and stored procedures. You just can't do stuff like, I don't know, write C# in stored procedure like you can do in SQL Server. But then again, who here is writing C# in stored procedures? That proves my point. So we saw how to migrate our databases to SQL database. And the next thing I want to show is how to migrate our content, our resources. So in the application that I'm using, you saw that I have images of agents, right? Now, those images, I can replace them in my application. I can, of course, add new agents and therefore add new images. The images are part of the resources that I keep for an agent. So I have the database that keeps all the metadata about an agent, but I also have a location, a file storage somewhere where I keep the agency's images. Okay? So one thing that I want to do before I migrate my entire application to the cloud is actually move those resources to the cloud. Because eventually I won't have one server that manages my application. I will have a couple of servers, load balance servers in a cluster, and those servers needs to be able to upload images to some shared location, pull those images from a shared location, maybe even offer those resources if those images, for example, through a CDN server. Are you familiar with the concept of CDN, Content Delivery Networks? Yeah? Okay. So in Azure, we have something that is called a storage account. Storage account, or to be more exactly, blob storage account, is actually some sort of a file share. But it's not a file share where I can go to a shared folder or a UNC path. This is actually a file share that is accessible through HTTP. HTTP GET request will retrieve the file. HTTP PUT request will place the file in the storage. Of course, it's secured, so I can create files, resources, place them in blob storage, and have them private, so I can only access them using a special code. I can have them public, which will allow everyone to access them. So for example, I don't know, CSS files, JavaScript files will probably be public, but those agent images will probably be private, and you'll have to authenticate against my service first in order to get them. So you won't be able to get the images of all the secret agents and therefore find them and kill them. Okay? So blob storage allows me to have all that. The only thing I need to do to get blob storage to work is first create the storage account. It's just a matter of a couple of clicks and waiting for a couple of seconds. And then I get this entire space where I can locate content. It's a huge space. I can have up to 500 terabytes of data in one storage account. And I can have up to 10 storage accounts in my single subscription. Okay, so if you have multiple subscriptions, you can have petabytes of data available to your disposal. Of course, hopefully you'll have a company that is able to use those petabytes of data. Great place to upload movies. So let's go ahead and do this for our application. The only thing that we will need to do in the application after we create a storage account is, of course, upload the resources to that blob storage. And I will need to change my code to retrieve the content from blob storage instead of from my local file system. Okay? So first of all, I'll show you what I mean by using the local file system, and then we'll create the blob storage. So in my application, let's run it again. You saw that I can select an agent, right? Let's just log in. Nope. I can select an agent, and this agent is retrieved from the local file system. If you look at my application, there is a folder called images, and inside it there is a folder called agents, and here is the list of agents and their images. To get that, how many people are familiar with ASP.NET Web API? Web API. Okay, so I'm using Web API here to retrieve the information, both the metadata, the name of the agent, and the photo itself, because I want it to be secured. I don't want it to be globally available. So I need the user to first authenticate, and then I will provide them the photo. So in my service, I have a special formatter called an agent image formatter, and I'm just pulling that file locally from the file system using a file stream object. Okay, so they are asking for a specific agent. I go ahead, pull the file, and provide them with the file. I want to change this to pull the file from blob storage instead from local storage. And of course, if I choose to replace the file and replace it with the real bond, I want the application to be able to go ahead and upload that file that I'm uploading to my web application and upload it to blob storage. Okay? And this is, of course, the real James Bond and not any other actor that is trying to play it James Bond. So first of all, I need to change my code. Okay? To change my code, instead of just coding it right now, I'll show you the code itself, and we'll explain exactly how it works. So we have another project here that is called the agency blob storage. And instead of just changing the formatter code, what I did is I added just another formatter. This is called agent image blob formatter. And I'm just replacing this formatter with the previous formatter. So what does this blob formatter does? So first of all, I'm creating a connection to my blob storage. Okay, I'm using the Microsoft Azure SDK for blob storage. Just let me show you where I got this from. Go to NuGet packages. Everyone is familiar with NuGet packages? Yeah, great. So you'll only need to write Azure storage. Okay, and there is a package called Windows Azure Storage. Okay, so this is the install package. Of course, go to online, search for that, and download that. That will give you the entire SDK to access blob storage, and of course the other storage types, table storage, queue storage, and those storage types. So I'm creating a cloud storage account. I need to provide it with the information for my storage account that I created already. I'll show you in a second how to create a storage account. Create a client for blobs, and get a container reference. In blobs, we have containers. Containers are folders, root folders of such. And inside the container, I can have files, multiple files, infinite number of files. Okay? So I just need to get the name of that container. And now when someone wants to retrieve a specific image, all I need to do is, from the container, get a reference to a specific blob. The blob is named after the ID of the agent, so I just need to get the ID. I'm using toLower just because blob storage, unlike file storage, blob storage is case sensitive. So just so I won't have mistakes of bond with a capital B or with the lowercase b, I'll just put everything toLower. And of course, when I upload the resources to blob storage, I will also make sure they're uploaded using a lowercase file name. Okay? Create a cloud blob object that represents that object represents the blob that I'm going to download. And then the easiest way, just download it to a stream. What kind of stream? The output stream of my HTTP. So this is actually downloading it directly from the blob storage to my response, providing it for the client. Okay? So of course, the first thing I need to do is upload everything to the cloud. So to create blob storage, the easiest way is just go to the management portal. It's just here. Go and scroll to storage. Okay, as you can see, I have a bunch of them here. Click new. It shows here storage, quick create. Just provide a name, the place where you want to locate that storage, the data center, and the replication. Storage accounts are automatically replicated to 3 different locations in the same data center. This is what we call locally redundant. That way, you always have a backup of the content that you placed in blob storage. because blob storage eventually uses hard drives, SSD disks. If something happens to that SSD, you won't want your content to be lost, right? And you won't want to back up the blob storage on your own, because that means copying it from one place to the other all the time. So Azure automatically copies or replicates your entire blob storage content to 3 different places in the same data center. So you always have 3 replicas of the files that you're uploading. This is locally redundant. If I choose geo-redundant, it will actually be copied 3 times in the same data center and 3 times again in a second data center. Okay, that will of course happen asynchronously, so it won't harm your performance. But you are assured that if, say, an asteroid hits the data center, or the data center explodes for some other reason, I don't know, a volcano eruption, then your data is backed up in a second data center and it's okay. Of course, if an asteroid hits a data center and blows it up, we have bigger issues than our data, right? So I can choose either geo-redundant, locally redundant. Zone redundant is 3 copies, either local or geo, to the decision of the data center where to copy that, okay? So I won't create it right now because I have a lot of data centers with a lot of storage accounts. So I will use my Azure Training Ido F storage account. So I need to copy the files. I'll go to my application. I already logged into my Azure Training Ido F. To get the key to the login, just go to the management portal, select the storage account, and click Manage Access Keys. Here is the key. This is the one I'm going to regenerate after this session. Okay. Not that I don't trust you, but it's recorded, so there are millions of people that are going to try and use my storage account. So here I have this agency images container that I created, and as you can see, I already copied the files. Of course, every file is lowercase, just so I won't have any issues. Now, I also need to handle the upload of the file, right? So back to my code, I need to handle the action in the web API that receives the stream of the file, and instead of saving it locally, I need to save it to blob storage. So I'll just go to my service, which is just down here. And using the same SDK, which I added to this services project, I will go to my method, which is called upload images from form. Place in comment the entire code that deals with the local file system up to here. And just uncomment the part that saves to blob storage. So this is the same code, the same initial code. Create the storage account, create the blob client, create a reference for the container, create a reference for the blob, again with lowercase. And then instead of download, I'm using upload. So I'm giving it the upload stream, the stream that I got from the client. In this case, this is a memory stream because I already pulled all the binary file content from the request into my memory. I'm using a multi-part memory stream provider if anyone is interested in the web API implementation. And I'm just uploading that stream to blob storage. Okay? So I'm using the SDK to both download and upload. This is the first option that I have. And we can now run this code. Let's go here to blob storage. Run the code, wait for a couple of seconds for the application to load. I'm authenticated. Let's select bond, choose file, real bond, replace. And here I have the real bond. I need to shrink that image a bit. And if you go back to the blob storage and refresh, of course, you won't see any difference because I'm overwriting the file. But if I'll try and open this file, I will see that this is actually the new bond. Okay? If I replace it again with the previous image, go back here, refresh, same file, open it, and now I have the file. Okay, so it's just uploading and downloading from blob storage. Okay. Of course, I can also use this blob storage as a location for my other resources, my public resources. For example, I have images on the website. Okay, this is an image, a public image. I don't care if people download it. I don't need people to authenticate in order to get it. So this is a public resource. I can, of course, have users download it for my web application, but that's just traffic that I don't need in my application. I can move my image to a public storage, okay, somewhere where I don't have to worry about performance and throughput of requests, and just make sure that my application, my web application, handles requests for web API, not handle requests for CSS and JavaScript and images. I want that aside in a different location. So I can go on ahead and, for example, create an additional folder for my resources, and in my resources have all the different images of my application. For example, here, this SAM logo is the logo of my application. Okay? I'll put that in blob storage, and now I want to just point my URLs in all of my images to point to that blob storage. So of course, if you have an application with dozens and hundreds of pages, that means a lot of work, right? Luckily for me, I know IIS, and there is a cool thing that is called URL rewrites. So I can just go to my web config. Just close this. I can just go to my web config, and under System Web Server, I can just place a rewrite that says the following. How many people are familiar with URL rewrites in IIS? Okay, so in case you knew or didn't know, when you create a URL rewrite, it's not only for incoming requests, it's also for outgoing responses. What does that mean to change a URL on the outgoing response? It means that it can actually check the HTML file, search for specific tags, such as an image tag, an image element, and change the source, the URL that appears in the source. And of course, not only for image, for anchors and A element, CSS, JavaScript, anything that has to do with loading another resource. So this uses a precondition of isHTML. IsHTML means that the content type starts with text/HTML. And I'm just searching for tags that are named IMG. Those are the image tags. Okay, any value that they have there, I'll just go ahead and replace those with, this one is in comment, but let me show you, HTTP, Azure Training, Ido F. This is the name of my blob storage. This is the address. After that, this is the name of my container. And then two lower, of course, just like before. And R0 is, of course, the value that was found. This is a regular expression, the value that was found here. So I'm just taking the relative image name and concatenating it to a path to my blob storage. Now, as you can see, this is blob storage, but I also have an option to use CDNs. Okay. Let me just discuss CDNs for a second, and then we'll get back to the demo. So how many people say they're familiar with CDNs? CDNs? OK. So content delivery networks are basically an implementation of what we once knew as a proxy server. So a proxy server basically is a server that stores all the responses that you got from the web, so you will get them faster, right? But the proxy server is a server that is located near you, and it's a single server. If you're in the UK, you have a server here in London. If you'll be, for example, I don't know, in Germany, you'll need to have another proxy server in Germany, but that will have a different address. So you'll need to use a different proxy server address in your browser configuration. So instead of that, content delivery networks are actually a set of proxies all over the world that have the same server name, the same DNS name, but that DNS name resolves to different IP addresses in different parts of the world. So I can use a CDN name called x.cdn, and in the UK it will resolve to some specific IP, and in Germany the same DNS will resolve to a different IP of a server that is in Germany. So a CDN is basically just a network of proxy servers that can provide you with resources such as CSS, JavaScript, HTML files, images, as closest as they can get to your location. Okay, so we do have the option to create CDN networks in Azure. The only issue is that it takes about an hour for it to catch up because it needs to be synchronized all over the world. So luckily, I already created a CDN for my blob storage. You can create, by the way, CDNs for both blob storage and for Azure web hosting. So you can actually have, if you have HTML files on your web hosting, you can actually have those files be backed up by a CDN. You just need to have your users browse to the CDN address instead of browsing to your local address. Okay. So I already created a CDN. Let me just show you where it is in the management portal. Just scroll down a bit, and there is a CDN option here. Click New if you want to create one. Quick Create, and it just asks you which storage account, which website, or which cloud service. These are hosting options that you have, hosted applications that you have in Azure, and they can also be accessed through a CDN. I already have a CDN created for my, for my Azure Training Ido F blob storage, and this is the address of the CDN, 652292, and this is actually the address that I have here. Okay, so what will happen is that the first user that hits the CDN in the UK, the CDN won't have that file available, so the CDN will call to my blob storage, get that file, store it locally in the CDN server, and provide it to the user. The second user that will try to access the CDN will just get the file from the CDN, and therefore will be able to get it a lot faster. Okay, so I'll just keep this rewrite that says change every URL that you get to use the CDN. Now, I already did that, so all I need to do is to check that it's actually working. So we'll open Fiddler. How many people are using Fiddler? Okay, you're all web developers, right? Okay, I expected everyone to use Fiddler if they are web developers. We need to talk afterwards. Okay, so let me get back to my application, and I'll just refresh it entirely with Control F5. Just to get all the resources reloaded instead of being loaded from the cache. Go to Fiddler, and if I scroll, you'll be able to see that although most of the resources were fetched from my server, this specific resource was fetched from the CDN. Okay, double-click this, and you will see that this is actually, let me just select the image view. This is the image that I got. So I got it from the CDN, which got it from my blob storage. Okay. I could have, of course, also uploaded to blob storage all those CSS files and the JavaScript files. The only problem is, as also explained in this slide, when we upload stuff to production, usually the CSS files and the JavaScript files get bundled. So we only have one URL that represents all of our CSS files. So we need to first bundle them somehow and then get that bundle and copy it to blob storage. Okay, otherwise, we'll only be able to use blob storage in debug and not in production. There are a couple of, by the way, solutions for that to automatically create bundles upon deployment, and after you deploy your website to production, copy those bundles to website. There are automatic scripts that do that. Okay, so if anyone is interested, let me know at the end of the session. I'll point out the URLs that describe that. So just to conclude this part, we created blob storage accounts. We uploaded the file to blob storage, changed our code to both download and upload the content to blob storage. And for public resources, we just pointed our code, our HTML files, to use those public resources. Okay. I didn't show how exactly, but when you create a container, let me just show you this part. When you create a container, you can actually select if this container is, just change this, if it's public or if it's not public, meaning private. Okay. And when it's private, no one will be able to access it through the URL, only if they provide a specific code that either is that primary key that I used or a special code, a one-time code that I'm providing to those users. So now that we have our application use data in the cloud, SQL databases, and blob storage with CDN, the next part is, of course, grab that application and upload it to Azure, right? I don't want to use my local host anymore. I want to use an Azure hosting environment. So it's time to handle the hosting itself. There are a lot of ways to host web applications in Azure. I can create a virtual machine, install IIS on that virtual machine, and then upload my application to that IIS server. Of course, we won't want to do that because then we'll need to manage that server, back it up, handle all the deployment scripts ourselves. It's just a pain in the neck. Instead, we can use web hosting that is part of the Azure environment. This is called websites. Azure Websites is basically an IIS server that is already created for you and just requires you to grab your application and upload it to the cloud. Azure Website manages everything for you. It will create a special folder somewhere and place your entire application in that folder. It will take a couple of servers and have them point to that location, so you can have a set of servers, a scaled website using 2, 3, 10, 15 servers. It will handle the configuration for you, meaning it will copy the configuration between the servers, so you will always have the same configuration in all the servers. If you change the configuration once, it will change in all the servers. You can actually open IIS management, the management console, and connect to that Azure website to change configurations such as compression, authentication, or well, authentication not, because there is no Active Directory there, but say like, I don't know, add custom headers and such. You can manage that through the IIS management portal. You can even have custom domain names. You can even have SSL certificates. You can even get all the diagnostic logs, the IIS logs, the HTTP logs. You can even include installed add-ins that get event viewer logs. Okay, you can even pull memory dumps of your W3, WP worker process from those hosting environments. Okay, but basically you don't need to handle the servers. It's cloud environment. You get virtual machines that are created for you in a matter of seconds. Let me just show you how I'm doing that. Let's just go ahead and create, for example, 2 servers that will host my website. And these 2 servers will have, say, I don't know, 4 cores each. That sounds okay? Enough for a decent web application that manages secret agents around the world, right? So let's go ahead and click New. Website. I click that. It's somewhere here on the right, right? No. Website. Thank you. Name. The agency 3. That's because I have 1 and 2 already. This is available. Web hosting plan. Let's create a new one. This is called Standard 2. Let me show you the options that we have. So we have an option, for example, to create a 4-core machine, where you can create a 2-core machine, a 1-core machine. We can create standard and basic. The difference is, of course, how much you pay, but not only that. The standard, for example, can be auto-scaled. So if the environment sees that you're consuming too much memory, too much CPU, it will actually add more servers. If it sees that you're not using enough memory, enough CPU, it will remove some of the servers. Of course, according to settings that you define, minimum and maximum number of servers, minimum and maximum amount of memory or CPU, okay, which is kind of cool. The basic, you'll have to scale it up and down on your own. Okay, just monitor the system, see if it's consuming a lot of memory, and then add another server. So let's create, for example, you know what, I don't know if I have enough CPUs. Let's create a standard one. By the way, you can even create a free one, but a free one doesn't allow you to do almost anything. Let's place that in North Europe and create that one. Okay, so I'm creating a virtual machine that will host my web application. This is a single virtual machine. I want 2, so I'll just wait for it to be finished. This should take about 2 more seconds. Okay, maybe 5 more seconds. Okay, maybe 7 more seconds. Come on. Shouldn't take more than a minute at max.
Why did you choose the website instead of a cloud service?
Instead of a cloud service, because we don't have enough time to wait for a cloud service to be created. Cloud services take up to 10 minutes to be created. There are other reasons why to choose websites over cloud services, but unfortunately, this is not my session about hosting strategies in Azure. But there are a lot of reasons to prefer websites over cloud services, mainly ease of development and ease of maintenance. Okay? Cloud services are sometimes preferred when you need to troubleshoot your servers because you can remote desktop those machines. In websites, I can't remote desktop. So I have the web application here. I can just scroll down here to scale and say I want, for example, to start with 2 servers. Let me just turn off the auto scale and just say I want 2 servers. Save. And again, takes about 5 to 10 seconds. Success. I have now 2 virtual machines that will host my application. All I need to do now is grab my application. Let's go to the demo slide. Grab my application, which was this blob storage, publish. Of course, I already connected Visual Studio to my Azure account. You will need to do that the first time you want to use Azure from within Visual Studio. Let's go to the beginning. Select Microsoft Azure websites. It will automatically retrieve the list of websites that I have. I also have the option of using new here to create a new website. The problem here is that this dialog is not advanced enough to select the standard modes versus the basic modes. It doesn't allow me to create 2 instances. Okay, it creates just a free web hosting, which then I need to go back to the management portal and change that. So I created that through the portal. Here it is, the agency 3. Okay. Next, publish. That next publish is the steps where I can change the connection string that I'm using in the deployment. The second one is to allow me to preview the results and verify which files are going to get copied. Okay. When you publish a website like that, it will use MS Deploy, which what it basically does, it compares your copy with the remote copy and copies or replaces the files that are different. That is why the first time, of course, the solution is empty in the cloud, so it will take it about a minute or 2, depending on the size of my application and my bandwidth. The next time I'll update a single file requiring me to update a single DLL, it will take about 2-3 seconds. That's also a difference between websites and cloud services, where redeploying an application in cloud services takes about, 5 minutes, okay, instead of 5 seconds. So I can now browse to the application. As you can see, in the browser, the address that I got is the agency.azurewebsites.net. This is, of course, a custom domain name of Azure Websites. If you have your own domain name, you can just map your domain name to that domain name using a CNAME or an A address. And as you can see, my application is running. Of course, I can also use HTTPS here. I can bring my own certificate and attach it to the application. I can now log in. So I can see that it's also using my database. Okay. And here I get the information. And this is, of course, from CDN through blob storage. So my application is hosted. Is there a question? Yeah.
So obviously you publish from Visual Studio.
Mm-hmm.
Wouldn't want to do that in production environment. Is there a means of you publishing from a website to a website? So say, for example, your developer publishes
Yeah.
Visual Studio to
Yeah. Okay, so the question, I'm just repeating the question because this is recorded and no one can hear you. The question is about deploying to production after completing an update step, right? I'm developing the application, deploying to production, then I'm creating a new version and I want to deploy. So what we usually do, and it is available in websites, we can create another slot, another web application on the same servers. we'll create something that is called a staging slot. We'll deploy the application there. That web application has a different URL. The URL, the agency dash staging, that Azure Websites.net. You'll check the application there, verify that it works. Okay, and then when you're ready, you'll do what is called a swap. A swap will basically just replace the DNS names of your production and your staging, and that way the staging will become the production will become the staging. And users will now browse to the production and will get the new version. The staging one, it's just for backup in case you have, I don't know, a critical error after 5 minutes of running and you need to revert back to your original version, so you can just swap back. Okay? And that also exists in cloud services, so it's a cool feature of both hosting environments. Now, of course, right now I have 2 servers, and these 2 servers, of course, share the same machine key, okay, because you wouldn't be able to scale your application if you're not copying the machine key between the 2 servers, right? Anyone had a problem and discovered that they need to change the machine key? Usually you find that there is something called machine key when stuff don't work, okay? Unless you took a course about ASP.NET and they taught you that. So you actually don't need to set the machine key in your web config. Azure Website, since it handles all the scale up, it automatically configures the same machine key in all the instances that it creates for you. Okay, so as you saw, I didn't need to change anything in my case. And if I'll add some code to show you the machine key, you will actually see that it's the same machine key in all of the servers. I actually have that code here, so if you'll just be nice, I'll show it to you. Are you nice? Nice. Okay, let's try that. So I have some code here. It's here. And this code pulls the machine key after I store that and just places it in the response headers. So I have some code to show the decryption machine key, the validation machine key. There are actually 2 keys. Also, I'm showing the session ID, and I'm showing the server name, just so you'll see that I'm using 2 different servers. Now, I already deployed this application. This is deployed to the agency 2, I think. Let me just check that. Publish. The agency 2. We are using the agency 3, but can do that. Let's just delete cookies, because cookies are a problem. Okay. Two. Let me just verify that I get the correct page. Another thing that I did in this application, I removed a special cookie in Azure Websites called an affinity cookie. Are you familiar with sticky sessions? Right? Websites are sticky, meaning the application that you are running is actually running on 2 different servers. When you browse it for the first time, you get an affinity to one of these servers. The next time you will run the application, it will actually continue to use the same server again and again, because it stores locally a cookie with an affinity code pointing you to one of the servers. If you don't want that, there is a header that you can include in your responses, which will instruct Azure Websites to remove that cookie and not use it. So in my case here, as you can see, I don't have any cookie being returned. But if I go to the agency 3, just do this. Which is the one that we just created without removing the affinity cookie. Just see that I get back the response. Okay, and the response here has the ARR affinity. This is the affinity cookie. Okay, my application. Let's see if I got it right. Oh, I do have that cookie. Why do I have that cookie? I removed that cookie. Go away cookie. Okay, that sometimes happens for some reason. Let me just try to. Let me just make sure that it doesn't happen again. Let me see if that's right. For some reason, let me just try to publish that application again. Maybe it didn't get published correctly. Publish. Let me again delete cookies. I'm deleting the cookies because since I did a demo a lot of times and I'm using this application, the Affinity cookie is already stored locally. So I want to make sure it's removed entirely from my cache, just so when I browse to the website, I will get a clear view of the response and not some response that came because it had the Affinity cookie already on my machine. So let me just check that. Yeah, OK. So now, as you can see, I just had to clear my cookies. I sent the request without the cookie, and I got a response without the cookie because I have the instruction to remove that ARR cookie. It's quite easy to Google for it of how to remove it, but let me just point you to the name of that cookie so you'll know what to look for. The name of the header, sorry, not the cookie. You just need to include this one, custom header, add ARR disable session affinity equals true. That will instruct the Azure Load Balancer to remove the cookie. Okay. Now that I have the application, I can even go on ahead and reissue this request. Just verify. Great. Reissue that request, say, 10 times. That will probably make sure that some of those requests hit server A and some requests hit server B. Okay. Now I can go ahead and please observe the response headers. They will tell me exactly which server I'm using. So I have one server name BA5, and if I go to the next request, everyone is using BA5. Let me just check if I have two instances there. Maybe it's not scaled. Agency 2, yeah, it's a free one. No wonder there. Let's just edit that. OK, let's go to tier. This will be a standard. OK, saving. Success. Now let's just change that to 2 instances.
Does the Affinity cookie bypass the load balancer?
The Affinity cookie bypass the load balancer? Yeah. The Affinity cookie is actually behind the load balancer. The load balancer is for the multiple web farm servers that host your management environment of Azure websites. Think of it as you have your browser and multiple servers that manage websites, and behind those servers you have your own web servers. So the load balancer of Azure manages the multiple servers that manage the website environment, okay, that have the entire set of DNS names. And after that, you're getting pointed to one of your web servers according to the affinity. OK, so now we should have 2 instances for our web server. Let's issue that request 10 times. Should take a bit longer because these are actually new servers, so the application needs to load. As you can see, I didn't need to redeploy. I didn't need to change my code. Just change it from the free tier to a standard tier and get 2 instances of it. Give it a couple of seconds to load completely. Come on. OK. Let's check the responses. So we have F75. OK, as you can see, 407. I get 2 different servers here. And the same machine key is in every one of the servers. I didn't have to set that. The only different thing here, as you can see, I get, let's try to do that again. And do that again 10 times. The only thing that you might see here is that, for example, you see these 2 requests. There is a session ID here. The session ID doesn't get changed when I access 2 when I access the same server twice. But if I get directed to the second server, the session ID actually changes. Okay? And in the second server, of course, if I look for the 407 again, here you go, it's 0BC, and before that, it's, again, 0BC. So different servers give me different session storages. Now, that's logical because I did scale out, I did copy the machine key, but still the session is in process, so I need to change that if I want to share my session storage between these two servers, right? So how do I change a session provider, for example? I need to go to my web config and change the in-proc to something else. So how many people are familiar with how to change session provider in ASP.NET? 1, okay, 2, 3. So we do have a couple of options. First of all, as you can see, session provider is has a mode. The default mode is in-proc, in process. I can change that, for example, to, say, SQL Server. So I can actually save the session state inside the database and then put it from each of the servers, and then I will get the same session state in all of the servers. I can use a state server. State server is a Windows service that I need to host on one of my machines. We do that on premises, not in the cloud, because that means the servers need to be able to connect to each other, and we don't have that option working well in websites. And of course, we can do a custom, or we can just turn off, but we don't want to do that. So what I want to do is I actually want to use a different approach instead of a SQL database, because SQL database might harm our performance because I need to retrieve the session from a database on every request. Instead, I want to use a cache server. Are you familiar with caching solution? Memcache, Redis, yeah? So this is what I want to do next. I want to use a distributed cache that is available to me in Azure as a service. Of course, again, I can create a virtual machine, install Memcache on that virtual machine if it's a Linux or a Windows, scale that out, have a lot of gigs of cache available to my application. But why would I want to do that when I can just create a cache in a single click of a button? Okay, I can create a Redis cache. How many people are familiar with Redis cache? Ever heard of it? Even used it, mate? Okay, so Redis cache is one of the, let's say, I don't want to say oldest, but it's one of the most mature caches that we have. Not only for .NET, it is available to use in Java, in Python, in C++. It has a lot of client-side libraries. You can deploy it on Linux machines, on Windows machines. And the Redis cache in Azure is just a version of Redis deployed automatically on Windows Server. So with the click of a button, I can create a Redis distributed cache that has a replicated copy on 2 different servers. So I have the primary and the secondary, a master and a slave. And it automatically knows to fall back to the slave if something happened to the master. And then, of course, create a new master. I can create a Redis cache from 250 megabytes cache to up to 56 gigabytes of cache. Of course, pay accordingly. I can get a throughput of thousands of requests per second to that cache because it's an in-memory state server. Okay? So to create that, all I need to do is go to the management portal, click New, scroll down a bit, look for the Redis cache. Here it is. Specify the name, specify the tier that I want. The tier, let me just show you all the tiers. The tier that I want, I have standard and I have basic. The difference between the basic and the standard is that the basic doesn't have a replicated copy. So it provides a lower SLA. The standard does have a replication support, so it offers an SLA of 99.9%. Both of them, of course, are secured because it's a public service. So you have SSL communication to that service. You have an authentication key that you need to use. So the content that is passed on the wire, whether you put something in the cache or retrieve something from the cache, is encrypted. So don't worry about that. Okay? You can select, of course, a different size. So the price is somewhere between, I don't know, $8 per month and up to $1,122, okay, if you want to pay that much for a cache. So we will select a smaller one. I actually won't create that because it takes about 10 minutes to create that. I'll select the size. I'll select the subscription and, of course, the location where I want to place that cache. Better place that cache in the same data center as your application if you don't want to suffer from network latency, okay? So I already have this Redis cache. And if I'll browse my caches, this cache. As you can see, I have the agency cache here. It takes about 10 minutes to create that, so I don't want to show how long it takes. So I have this cache. Let me just get back and click it. And as I said, this cache has a special key that I need to use. So I just go to keys and copy this key. I know the address of it. I just need to get the port number and the full address, which is the agency Redis cache Windows.net. And now I need to use it in my application. So of course, since Redis is a very mature cache, it has multiple client libraries even for .NET. You have Service Stack, you have Stack Exchange. I'm going to use, I think, Stack Exchange. Let me see. Have this sample here. Okay, so in Stack Exchange, in my project, I installed the NuGet package for, let's see, which one is it? Stack Exchange .redis, okay? I actually installed a NuGet package that uses this NuGet package. I installed the Redis Session State Provider. Redis Session State Provider is a NuGet package that has a session provider that uses Redis by using the Stack Exchange client library. Okay. Once I add that NuGet package, I can also, of course, use Redis as a distributed cache instead of using the application cache of ASP.NET, which is wise because the application cache of ASP.NET is also in process. So I can just change my cache code to use Redis. That requires a bit of coding. But hopefully, if you were wise enough in your architectural stage to abstract the caching layer by using an interface, then you might be able to just download a sample of Redis and create a new implementation to use Redis cache instead of the application cache. So once I installed the Redis Session State Provider, I already got all the configuration that I needed inside the web config. So if you remember, the session was set to in-proc. Instead of that, I just got a section getting pasted in my web config saying session state mode custom provider, my session state store. And this one uses Microsoft.web.redis session state provider. You have here a sample of all the configuration that you can set for Redis. So in my case, I didn't need all of this configuration. I just needed the following settings. The host, the access key. Okay, this is why I'm going to regenerate it after the session. And whether I'm using SSL or not, it should be true if I want to actually encrypt my data. Just select false for this demo, so it will all go faster. Of course, there are options to, for example, change the timeout. You should change the timeout if you're testing it locally, not from Azure, because the default timeout is about, 1 second for an operation and 5 seconds to connect to the cache at the first time. Okay, so if you are testing it from the UK and your server is in the US, it might take more than 1 second to retrieve something from a cache that is in a US data center. So you might want to change that. So once I do that, let me just upload this solution to Azure. Publish. Let me place that in. We want that in the agency 2, I think. Let's select the agency 2. Come on. Oh, yeah. Need to close Fiddler. Sorry. What happened to the network? Publish. Now it seems to be working. Agency 2. Okay, clean all the cookies. Clean cookies. I feel like the cookie monster right now. Clean all the cookies. Okay, publish started. Publish should be done in about a couple of seconds. Okay, let me just open Fiddler because I forgot to open that. I need to make sure I don't have the affinity cookie, otherwise this whole demo won't worth anything. Wait for it to load. Any questions in the meanwhile, while it's loading? Okay.
Here's the URL to the tools which can help us to bundle up the scripts and CSS.
The tools to bundle up script and CSS, I'll have to find them in my browser history, okay? Because I saw that, but I didn't have a chance to look at that code. So just come to me at the end of the session and I'll find that. Okay, so the application started. I just need to make sure it's not using the affinity cookie. Let's do that again. Second time should be faster. Unless, of course, I'm using the other server. Okay, let me just check the response and make sure I don't have any session cookie. Great. Session, yeah. Affinity, no. That's great. That's what I wanted to see. And now let's reissue this request 10 times. Okay, so F75407, but as you can see, the session ID, okay, in both requests is the same. So I'm actually using the Redis cache to store those session items. Can, of course, if I want, I can open the Redis command line interface, connect to the Redis cache, and show you that it's actually there. But trust me, it's there. Okay.
Performance is the same?
The performance, well, Redis itself provides a performance of about a couple of thousand of requests per second with a latency of less than 1 millisecond when it's in the same data center. Of course, you'll have to test that. It depends on the size of the data that you're using. If you're using a direct cache or a set or a list or some sort of a dictionary, it really depends on how you're using Redis, okay? And the amount of data that you're trying to put or pull. The last thing we want to do is we want to actually change the way we authenticate our users, right? And throw away that user's database and the ASP.NET identity and instead use Azure Active Directory. So Azure Active Directory is just a user repository as a service. With the click of a button, I get a location where I can add users, add groups, create applications, application definitions that will allow me to use stuff like OAuth and OpenID in order to connect my web applications to Azure Active Directory. I can even enable two-factor authentication, which will require my users to, say, get text message with a special code when they are trying to log in, get special reports that will show me which users had attempts to break into the account. For example, they are from the UK, but someone tried to use their login from the US. Okay, or they had too many mismatches of the password, or the account got locked. So I can get all of these reports. This, of course, requires you to have the premium account, which costs a bit more money. And to do that, I'll just show you the end of this part, because it does take a while to create the Azure Active Directory in the application configuration. So I have here an application where I removed all the ASP.NET identity, and instead, I just added the security settings for Azure Active Directory. I'm using OWIN components here. How many people are familiar with the new OWIN pipeline for ASP.NET? OWIN pipeline? OK. Just to recap OWIN pipeline for those who are not familiar with it, OWIN pipeline is a new solution that intends to replace the IIS pipeline for compression, logging, user authentication, and stuff like that. So instead of creating a new HTTP module for IIS to replace my authentication layer, I'm creating an OWIN middleware, authentication middleware, to manage my authentication. Okay, it's a different pipeline, but it's the same concept as the IIS pipeline. The entire idea here is that I can eventually decouple my web application from IIS and maybe even host it in a Windows service. Cool, right? By the way, you can today host Web API in a Windows service. In the next version of ASP.NET, you can even do that for an MVC application. Okay? If you want, check for ASP.NET vNext. It's available in alpha right now. You can try to do that. So for the configuration, what I'm doing here, I just removed the entire ASP.NET Identity Owen components. I just left the cookie authentication. The cookie authentication will allow me to replace the token I got from Azure Active Directory with the cookie, so the user won't have to authenticate again and again. This is the session cookie that you might remember from previous implementations of the identity system. And what I'm adding here is an authentication middleware that uses WS Federation. WS Federation is one way to authenticate against Active Directory. Azure Active Directory, I can use OpenID Connect, I can use OAuth, I can use different protocols that authenticate against Active Directory. WS Federation will just redirect my user to Azure Active Directory, require them to enter user and password, and then redirect them back to my application with a special token that my application will examine and collect the information from it about the user. Okay, their name, their ID, the groups that they belong to, and that sort of things. Not the password, of course. My application won't need to know the user's password. So to use that, I, of course, needed to create an Active Directory. So Active Directory is in the old management portal. So I have my Active Directory here. I created that a long time ago, and I have a bunch of users here with a bunch of groups. I have a lot of applications that I configured, and the application that I'm using is this one, the agency Web Azure that I created before for this session. By the way, if you want to create this easily, just create a new web project in Visual Studio 2013 and on, and select, you know what, instead of telling you, let me just show you in it. It will just take a second. Just create a new web application. Select either MVC or Web API, and change the authentication to organizational accounts, cloud. Specify the name of your Active Directory. In my case, it's Ido Flatow, idoflatow.onmicrosoft.net, and select the application ID that you want for your application. Click OK. Enter the credentials of your admin account, and it will create all the configuration for you. You don't have to do anything. That's actually how I created the configuration for this application called the agency Web Azure. Okay, just created it for Visual Studio, and it just created the entire settings here, including the client ID and the application ID and everything that I needed. Once I have that configuration is stored in my web config. Okay, I already deployed this application to Azure. This is the original, the agency solution. And as you can see, I have in my web config, oh, sorry, it's here, not in the web config. I have the metadata address of my Active Directory. I have the realm, which is the name of my application, the agency. And all I need to do now is just run this application from the cloud. I already have this application deployed. So let me go to the agency, the original, the agency. And as you can see, the first thing that I get is a redirection to Azure Active Directory. I can enter my admin user here, Ido Flatow on Microsoft.com, and get redirected back to my application with my credentials, and it even says, hello, admin at Ido Flatow on Microsoft.com. I can, of course, also create a management application to add new users, which will use the API of Azure Active Directory to create the users in Azure Active Directory instead of giving them all admin accounts to the management portal, right? I don't want to do that. And now I've authenticated, and I can access my application. So it really didn't take that much to create the Azure Active Directory, since we have that wonderful wizard in Visual Studio. Now, of course, you're all waiting to hear how much it costs. But before I show you the price, because you'll be amazed. I don't know if for good or bad, but you will be amazed. Let's just recap the things that we did. We took our web application and got the user to browse to it in a website. To get to that website, they needed to be authenticated using Azure Active Directory. When they arrived to the application, their session ID was stored in an Azure Redis cache. The information was retrieved from SQL database in Azure. The agent's images were retrieved privately from a blob storage, and all the other public resources, such as the logo that I had in my application, was retrieved through a public blob through a CDN. Of course, I can also add a bunch of other stuff here, but that's enough for an hour and a half. As regarding pricing, of course, that depends what you need. On the low end, I can actually pay $0 for web hosting, but that won't give you a lot of space and quota. So a standard machine, a basic machine that has 2 gigabytes of memory, 1 CPU will cost you about, I don't think the $5, oh, sorry, where is it? $56, yeah. For the hosting itself. The database, the minimum that you can pay is $5 for a 2 gigabyte database, which is usually fine for people who create a small web application. At the bottom, you can see that a low-end server that has 100 gigabytes of throughput a month, you'll pay about $90. Okay, you can even lower that if you'll take a free website. On the high end, if you take a large database that has 500 gigabytes, if you take 4 machines for your website, if you take a Redis cache that has 1 gigabyte instead of 250 megabytes, you'll pay a lot more. Okay, of course, your website will probably be somewhere in between, maybe to the lower end and not to the far end. But it really depends on how much you are willing to invest and how strong you need your website to be, how large you need your database to be. Okay, but as you can see, the price is a lot lower than some of the hosting environments that you get if you want to, I don't know, just host your web application in some public hosting somewhere. So, of course, there are a lot of things that we can further discuss when it comes to hosting web applications. We can talk about how to install virtual machines that have SQL Server on them. We can talk about the new document database that is in Azure if you want to use a NoSQL database and a document database. We can even talk about table storage that is a way to host, to store, NoSQL data instead of using a relational database. We can talk a lot more about hosting, and someone asked before about cloud services. We can talk about the difference between cloud service hosting, virtual machine hosting, mobile service hosting, and versus web hosting with websites. Of course, if we are talking about hosting and deploying, we want to talk about continuous integration, deploying to staging and production, as someone asked before, the different deployment slots we can create, even how to run background applications inside our web servers. We can, of course, talk about Traffic Manager, which will allow us to scale our application, not necessarily in the same data centers, but between data centers. Have a couple of servers in North Europe, a couple of servers in the US, and have them being load balanced when users try to access them. We can talk about virtual networking and VPN and how to connect, for example, your web application to your on-premises database if you still need to retrieve some data from that database, or to local services that you have. That's also possible. And of course, not necessarily everyone is developing .NET. Okay, website supports Java and Python and Node.js and all sorts of other web application platforms that we have. Everything that can work under IIS. Okay, basically. We can also talk about diagnostics and troubleshooting. All of these features are supported in Azure. But for that, I would have needed to have a workshop here and not just a session. So maybe you should point that out to the organizers for next year. I don't know, depends. Resources. Go to azure.microsoft.com. If you have, how many people here have an MSDN license? So just know, everyone who has an MSDN license has between $150 to $200 of Azure resources per month. Okay, you just need to connect your MSDN subscriber to your Azure subscriber. You just need to create an Azure subscription while logging in with your MSDN Live ID. That will allow you to have $200 to spend a month on Azure resources. There is a training kit that you can download with a lot of walkthroughs and labs and another set of slides that you can learn about Azure. There are some great blogs. If you go to Scott Goo's blog, there are posts there that come out every couple of weeks showing the new features of Azure. So if you want to know what's new, go to his blog. And of course, if you want to learn about the coolest stuff in Azure and the pitfalls of Azure, just go to my blog, because I don't write about new stuff. I write about stuff that don't work and how to fix them. Okay, that's my blog. And of course, as I promised, the slides and the code, the samples are available online. Don't try to run them, at least not in the next couple of hours, because I'm going to delete all the resources from Azure, so no one else will be able to use them. And so my company won't have to pay those couple of hundreds of dollars for all the resources that I created now. So I'll be here for the rest of the evening and up until Friday if you want to come and ask questions. Thank you very much for coming, and I'm sorry that it took about 15 minutes more than we expected, but that's Azure. Stuff don't work sometimes, okay? So you have to wait. Thank you for coming. Enjoy the rest of the conference. Your hands? Okay. So first of all, I want to show you the application that we're going to migrate, just so you'll know what I'm going to talk about. So in this Visual Studio, and by the way, I already provided the entire solution, including all the projects, online. At the end of the session, I'll give you the link so you can go ahead and download the code. You'll probably see my keys and my URLs there, so don't worry, I'm going to delete all the resources later on, so you can't use my Azure Active Directory and my storage account. I'll delete those. So first thing, I'm going to show the basic application that I'm going to migrate. So this is an application that is using my local IIS Express. It's using a local SQL Server database, and it's in use. Let's just close some stuff here. Let's try that again. Okay, so this is a local web application. The database that it is using is a set of two databases on premises using SQL Server Express. I have one database for my application database where I have all my entities, all my resources, and another database to manage my users. I'm using the ASP.NET Identity System, what was once known as the membership provider, if you're familiar with that. So this is the application. This application manages secret agents such as this guy. Oh, no, sorry. Have to authenticate first, of course, log in. That's kind of weird, an application that shows you a list of all the secret agents before you're actually authenticated. So I need to discuss this with the architect, which is me. Okay. And now we can see this guy. Or, for example, I don't know, this guy. Familiar with him, right? OK. Everyone knows who this is. So this is my application. The entities that you see here were retrieved from this database, the agency DB. You can go ahead and select the rows from this table. OK. My management system, my user management system, is using the agency users database. As you can see here, my ASP.NET users. Okay, here are my users that I manage in the application. So the first thing I want to do is to think what I'm going to do with this application, how I will migrate it to Azure. So in this session, what we're going to do is we're going to show a couple of things. First, I'll try to move my database to the cloud, because I can't use an application that is in the cloud with a local database, right? Next, I'm going to see how I'm going to handle different resources that I have, files that I'm uploading to the server, local resources such as images, scripts, that sort of things, and how I'm going to manage that in the cloud. Next, we're going to talk about hosting, how to actually upload a web application to the cloud, how I'm supposed to host that, which solution is the best, and how we... That's done. It's a small database. It's about 60K in size. Of course, your databases are probably gigabytes, if not terabytes. If it's terabytes, I hope you have enough bandwidth to upload it to Azure. Okay. If not, by the way, Azure also has the option of sending them hard drives with the backup of the database, and then they will just put it in storage for you, which might be better than to upload an entire 10 terabyte file to Azure and wait for 12 days.
Just a quick question.
Yeah, quick question.
Which ports need to be open for you to be able to communicate from SQL Server through to the Azure database?
So to communicate from your local machine with a SQL database, you mean?
Yes. Obviously, I'm assuming that since we're talking Azure, we're talking about enterprise development, not someone sitting at home playing around.
Either. Wait,
So
I'm sitting around at home and playing with Azure. If you want to use SQL databases in the cloud from your enterprise or from your home, you need to make sure that you open the SQL Server port in your enterprise firewall, and in an outgoing port in that case, the destination port that you're connecting. The SQL Server port is 1433, if I'm not mistaken. That's the same port as a local SQL Server machine. But what you will need to do, and I will show it in a couple of minutes, you will need to do the opposite. You actually need to tell SQL database in Azure which IPs can connect to the database, because you won't want the entire world being able to connect to your database. Okay, so that's one thing I need to do in a second. So let me just create the agency users backpack. Okay, and we'll do this. Close. So now we have 2 backup files, and we need to create database from those 2 backup files. So let's move on to the management portal. And how many people are familiar with the 2 versions of the management portal? We have the new one and the old one. How many people know the old one, the existing one? I don't like to call it the old one, because for me, this is the main one that I'm using. Okay. How many people have tried the new one? Yeah. How many people are not going to try it because it looks strange? Right. Okay. From what I know, people either like this new portal or hate this new portal. They just didn't tell me how many people actually like it, because I don't think it's a lot. This is recorded, right? Oops. Okay. Maybe they will deny me MVP for that next year. So the first thing I want to do is to create a database server. In SQL databases, we have 2 things that we need to create. There is a SQL database server, just like we create a SQL server and installing the entire application on a virtual machine. We need to create this server. This takes about a couple of seconds. And the second thing I need to do is to create a SQL database, the database itself in the server. Just like we are installing SQL Server, we actually do that, and of course we'll show a demo. Then we're going to talk about scaling, session management, cacheability, and that sort of things. And of course, we're also going to talk about authentication, not because I'm a security junkie, but because when we move to the cloud, it's better to use the cloud support for security and not continue to use the ASP.NET Identity System, of course. So the first thing we're going to talk about is SQL databases. So of course, in the cloud, you don't have to use the built-in components for databases. You can just create a virtual machine and install SQL Server on that machine. But why would you want to create a virtual machine and install a database and have a DBA to manage that, or a team of DBAs, and manage the backups and the scalability and the reliability of those machines, where instead you can just click in a browser and create a new SQL Server as a service, okay? So this is one of the options that we have in Azure, to create a SQL database that you get as a service, as a managed service that you can actually just create in a click, even scale in a click. I can create a small 2 gigabyte database and increase it over time to a 500 gigabyte database that, of course, will cost me about 100 times more, but at least I won't have to manage that migration. I get a database that is backed up. I get a database that has copies, okay, a replicated copy both locally and even geo-replicated to another data center, of course, if I pay enough money for that, okay? Everything depends on how much you're willing to spend. So we have different offerings of SQL databases, And eventually, it will be wiser to use those solutions instead of creating your own SQL Server virtual machines. Okay, so how do we do that? How do we migrate our application from using a SQL Server that is locally to a SQL database in the cloud? So first, of course, we need to create that SQL database in the cloud. Okay, we'll see how to do that. Next, we need to migrate our databases, right? Export them from the local storage, from the local SQL Server, and upload them somehow to the cloud, and then import them and create a database based on those backups. Okay? We probably need to do that twice, once when we develop the application and another time before we go to production, where we'll probably need a couple of hours of downtime in order to back up the production database and upload it to the cloud. Lastly, change, of course, the code. I mean, it's SQL database. It's not a SQL Server virtual machine, right? So we probably need to change the code. We probably need to change how we use queries, how we use ADO.NET. If we're using Entity Framework or an Hibernate, we probably need to do that. To make long story short, you won't have to change your code. SQL databases in Azure actually use the same protocol as SQL Server machines, meaning that I don't have to change the way I access the database. The only thing I need to change in my code is, well, the connection string. Just point to the SQL database in the cloud instead of using my local SQL Server. Other than that, I don't need to change any of the code. That's because when I primarily designed my database, I designed it to be easily migratable. Of course, if your database is, I don't know, 10 or 15 years old and has issues like tables without proper primary keys, related tables without proper foreign keys, non-clustered indexes or clustered indexes, you might have some issues migrating your database. Luckily, when we perform the export, there is a tool in SQL Server, at least from 2012 and on, there is a tool that is called export application that creates a backpack file, BACPAC file. I have no idea what the acronym of that file name is, but that's basically a backup of your entire schema plus data. And once you issue that export, it will actually tell you what features are missing or not supported when you will migrate it to SQL databases, and it will actually inform you in each table and each column if it's correct or not and what you need to fix. So you won't have to, complete the entire process of importing it to Azure just to find out you can't use that. So even while you'll export the data, you'll get the proper messages if you can do that or not. Okay? And of course, fix it and then export it again. So let's try to do that, and then we'll discuss some of those disadvantages that are listed on the bottom. So as I explained before, the first thing I need to do is not change my code. Okay, instead, I just need to create the database and export my local database to Azure. So let's start with exporting my local database. I'll go to my management studio. I have the two databases here. Let's just close these. And what I can do, I'm using the management studio of SQL Server Express. I don't have a full-scale SQL Server machine, and there's a bit of a difference between the management studio of Express and the normal SQL Server. I'll explain shortly what I mean. When I go to tasks, I have the option of export data tier application. That will create the backpack file. In this version, when I export the data tier, it tells me to select the local disk path or to select Windows Azure and save it in some storage account. Okay? I can do either of these. In the full management studio, you actually have a third option of creating a database in Azure from your local database. So it does both the export and the import. Okay? I will have to do these two steps, but you actually can do that in one step if you have a full SQL Server. So let me store that locally for now. This is the agency DB. And in the meanwhile, I can do the second one. So, good afternoon, everyone. Welcome to the end of the first day of Software Architect. Unless you've been to the workshops yesterday, in that case, welcome to the end of the second day of Software Architect. In this session, I'm going to show a lot of demos, but most of them are going to be, well, web browsers, management portals, and some minimal coding. That is because we are all software architects and not necessarily developers. And if we would have come here to see code, I would have made you stay for the entire day because that would have been a lot of code. Okay? Because what we are going to see here in this next 60 to 90 minutes is how I can take a web application that I developed primarily on premises that is working with a local SQL server and the local database for identifying users, and migrate this entire application to Microsoft Azure and replace all the components that are used locally with components from the cloud. Okay, so that is what we're going to see. And just before we begin, just to introduce myself to those who didn't come to my workshop yesterday, because I see some familiar faces. My name is Ido Flatow. I'm a software architect from Israel, dealing a lot with Azure in the past couple of years, both architecting application for the cloud, migrating customers from on-premises solutions and even other cloud solutions to the Microsoft cloud, to the Azure cloud, writing training kits and courses about Azure, even wrote a couple of books, not about Azure, but about other stuff. But I do a lot of Microsoft consulting, a lot to do with .NET, databases, IIS servers, cloud development, etc. So if there is anything to know about cloud, I bet I'm your guy. So try me out at the end of the session with every question that you have. So what are we going to see in the next couple of minutes? We're going to see an on-premises web application that I developed that is using, of course, a browser, a web server, and a SQL Server database. And for authentication, the application is using the ASP.NET Identity System. So first of all, before I begin, how many people here define themselves as web developers or web architects? Many. OK, that's great. How many people here, by the way, ever used Microsoft Azure? OK. How many people are going to try it out at the end of the session? Everyone, raise